Lesson 15 in Module 1 is on equations of graphs of proportional relationships involving fractions. So again, I want us to keep in mind what we're dealing with proportional relationships. We are dealing with straight lines going through 0, 0. We're dealing with constants and finding unit rate. None of that's changing, even though we're involving fractions and still working with the graph. So let's take a look at what's relationship with fractions and graphs proportional relationships. So Sam's mother had entered a 10K race. 10 kilometers. They want to show their support, but they want to figure out where they have to be along the race. So it says previously his mother ran a 5K race with a time of 1.5 hours. Ooh, sorry, that was bad. 1.5 hours. And we're going to assume they ran at the same rate, there's the constant, as a previous race in order to complete the chart. Create a table that shows how far Sam's mother has run after each half hour from the start of the race, and we're going to graph it and then answer some questions. So if we're going for each half hour, notice this right here, our X column and our Y column, independent and dependent. If we're going by half hour, there's half an hour, 1 hour, 1.5 hours, 2 hours, 2.5, and 3 hours. All right, well, we know right here she ran 5 kilometers in 1.5 hours. So here's 1.5. So she ran 5. Now what we want to do is use this information to figure out the rest of the chart. So like we've been doing, we want to take this right here and we need to find our constant with it. So since we know both of the X and Y here, we can find our constant. Sorry, it's pretty sloppy, but you get the idea. And our constant, remember, is our unit rate, which is our Y divided by our X. 5 is our Y. X is our 1.5. And we're just going to divide these out. This is 5 over 1 divided by, if I change this into an improper fraction, 2 times 1 is 2, plus 1 is 3. And then don't do this next part before you write it out like this. Keep it, switch it, flip it. Now we can cross reduce, 1 in common, only 1 in common, so then we go 5 times 2, which is 10, over 1 times 3, which is 3. So our constant is 10/3. So what that means is we're going to multiply all of our X values by 10/3. So if I go 1/2 times 10/3, I can just multiply straight across. 1 times 10 is 10 over 2 times 3, which is 6. I could divide both of those by 2. 10 divided by 2 is 5. 6 divided by 2 is 3. And if I wanted to, I could rewrite it as a mixed number. 3 goes into 5 one time, and there's 2/3 left over. Sorry, running out of room there. Then I could take 1 and multiply it by 10/3.
Something smells like burnt popcorn.
Anyway, anything times 1 is just going to stay the same, so that's going to be 10/3. Or 3 goes into 10 3 times, that's 9, and there's 1/3 left over. This one's already done. I'm really sorry, I should have picked a different color to do this with. 2 times 10/3. Remember, if we put a 1 underneath this, we can go 2 times 10 to get 20, and 1 times 3 to get 3 on the bottom. That would work out to be, if we want to mix number, 3 goes into 26 times, that's 18, so 18 out of 20, there'd be 2/3 left over. All right, let's do this one. Let's go 2.5 times 10/3. This one we're right over here. So I'm going to change this into a mixed number. 2 times 2 is 4, plus 1 is 5, so this is 5/2 times 10/3. I could cross reduce here. 5 and 3 have a common factor of 1, but 10 and 2, 2 goes into itself 1 time, 2 goes into 10 2 times. 5 times 2 is 10, 1 times 3 is 3, and we get 10/3. No, I don't. I messed that up. And I bet you're sitting there going, Mrs. Messing, you are wrong. Let's try this again. 2 goes into itself 1 time, 2 goes into 10 5 times. Better? I hope so. 5 times 5 is 25. So we could write this as 25/3. Or 3 goes into 25 8 times. That's 24, and there's 1/3 left over. And finally, times 10 thirds. Write that over 1. 3 times 10 is 30. 1 times 3 is 3. And, well, 30 divided by 3 is just 10. All right, so this is super messy, and I'm sorry, but I want us to focus on these numbers here. I'm going to rewrite them in blue because it's easier for me to see. 1/2 and 1 2/3. That's an ordered pair. That's an x value and a y value. 1 and 3 1/3. 1 1/2 and 5. Okay, and you can kind of keep going with this. Let's put these on this chart here. So 1 1/2, so a half is about right here. And then we go up 1 2/3. Well, 1's halfway between here. Notice our scale. We're going by 2, 4, 6, 8. So here's 1 2/3 would be almost the 2, but not quite. 1 and 3. There's 3 right here. And up a little bit for a third. And again, we're approximating, guys, so it's okay that we're not perfect. 1 1/2 will be right here in between, and we go up to the 5. 2 and 6 2/3. Almost. Okay, sorry. Interruptions again. So if I mess up a little bit here, I apologize. It looks, though, like I'm at 2 1/2. 2 1/2 and 8 1/3. So here's 2 1/2. Now I go up to 8 1/3, a little above the 8. Make my dot bigger there just to make it work. And finally 3 and 10. Okay. So what does this graph look like? Let's see if I can. If I were to draw a line through here, okay, not perfect, but if I draw that line, what do we notice? Hopefully nothing that is surprising us here. Because it says, what are some specific things you notice about the graph? And the graph is the line. Well, it looks straight to me. And it also looks like it's going to hit at 0, 0. So what do we know if a graph is a straight line hits through 0, 0? It is proportional. Okay, which makes sense. We anticipated this being proportional if she is running at the same rate, right? Okay. Does it matter that they were fractions, that it's going to change from being proportional? Nope, it doesn't. So what's the connection between the table and the graph? Well, are they different? No. There are two different ways of applying the same information. So I'm going to say same point, which means same information. And as before, what does this ordered pair mean? We've done this before. It doesn't matter that there's a fraction. Remember, this is our x value and this is our y value. Our x values are our time and hours. So in 2 hours, what is our y value? Or y represent the distance she's run in kilometers. So in 2 hours, she runs, sorry, that's really sloppy. She runs 6 2/3 kilometers. Hopefully this seems familiar to you because we really are doing the same thing. Having fractions, whether they're in graphs or in tables or whatever, doesn't change the idea of what it means to be proportional.